Yes, hello everyone. Welcome to Unacademy and welcome to this session. So, guys, listen to our new anthem, that is Let's Crack GATE and ESE with India's largest learning platform. So, guys, before proceeding further, let me introduce myself. Guys, I am Krishan Dev. I did BTech from NIT Silchar in CSE. I also studied at IIT Ropar and at JNU New Delhi during post graduation. Along with that, I am GATE as well as NET JRF qualified in CSE. And finally, if we talk about teaching experience, then guys, I have more than 4 years of experience in GATE CSE. Okay, now let's talk about Unacademy. So everybody knows about Unacademy, that is India's largest online learning platform. So guys, you can download Unacademy learning app from Play Store or Apple Store. And after downloading, what you are going to get, I am going to explain one by one. The very first thing is daily live lectures. That means every day there will be some live sessions. So you guys can participate in the live discussions as well as you can raise your doubts and queries in the live sessions. Second one is live test and quizzes will be provided on Unacademy. These tests and quizzes will include first one topic wise test, then secondly subject wise test, and finally mock test and full length test also. Yes, third one is structured courses. That means the courses provided on Unacademy are in very structured manner. And final one is unlimited access. That means once you get the subscription, then you can access the plus courses. And you know very well on plus courses, you will see every course is in very comprehensive manner. And by chance you miss out the live lecture, then the same lecture you can see in the recorded form also. I think that is the greatest advantage. Now, you know very well on Unacademy, India's topmost educators are there. So you can see various courses are available on Unacademy platform. Finally, let's talk about subscription plans. So once you take the subscription, then you will be able to access the plus courses. And I already told you guys in the plus courses, every course or every subject will be covered in very comprehensive manner, and also you will be provided some live tests and quizzes, and these tests and quizzes will include firstly topic wise test, then subject wise test, and finally mock test and full length test also. So those students who are BTech appearing, they can also prepare for their semester exams as well as for their campus placements also. You can see on Unacademy platform, various coding related courses are also available. So guys, you can prepare for your campus placements as well as interviews and all. Okay, with the same subscription, you will be able to access the all these courses. Okay. So guys, for instance, if you want the subscription for 24 months, then the amount is 30,000. So use my code, that is DEV1 DEV1, and get a discount of 10%. Then the final amount after discount will be 27,000. Similarly, if you want the subscription for 12 months, then the amount is 25,000. Again, use my code DEV1 during subscription DEV1 and get a discount of 10%. Then the final amount after discount will be 22,500. Similarly, if you want the subscription for 6 months, then the amount is 20,000. Again, use my code, that is DEV1 DEV1, and get a discount of 10%. Then the final amount after discount will be 18,000 and so on. Isn't it? So guys, if you guys want to subscription, then take the subscription as soon as possible, because there will be a hike on the price from 20th of October. Okay. So those students who want to take the subscription, then take it as soon as possible. Okay. Yes. So guys, these theory lectures will be followed by some live tests and quizzes, and these tests and quizzes will be conducted on Unacademy learning app. So I would suggest you guys that first download Unacademy learning app from Play Store or Apple Store, and after downloading you can follow me on Unacademy, and my profile link is given in the description of this video. From there you can follow me so that you will be getting the notifications regarding live lectures or live test and quizzes. Okay. Yes, good evening guys. Yes. Yes, am I audible or not? Tell me once. Am I audible or not? Yes, I will inform you on the group. Okay. Whenever there will be a test or quiz, I will inform you on the group. Okay. So Telegram group, I think you joined the Telegram group. Otherwise, if you want to join, then the link is given in the description of this video. From there, you can join the Telegram group. Okay. I will update anything regarding test and quizzes on the Telegram group also. Okay. Yes, good evening. Okay. So guys, yesterday we were discussing some conversions from logical statement to English statement as well as English statement to logical statement. Okay. So write down one more problem. Yes, based on that particular topic only. Yes, that is given to you. Yes, some boys in the class are taller than all the girls. That is the English statement given to you, and we need to convert it into logical statement. Okay guys, that is the given statement. Yes or no? So we'll take two variables, one for yes, one to represent boys and another variable to represent girls. Okay, so we can see that some boys, yes, some boys means there exists x, yes, boys of x. Yes or no? Yes or no? And yes, if it is a boy, then we can say that, let's say one more variable for girls, that is, let's say y. So for every y, if it is a girl, then we can say that yes, we will take one propositional function, that is, let's say taller x comma y. Yes or no? So meaning of this one, taller x comma y will be, yes, we can say that, yes, we can say that, yes, x is taller than y. Isn't it taller than y? So you can see, because of this existential quantifier, there will be AND operation, and because of this, yes, universal quantifier, there will be a implication. Yes or no? Tell me, this one is clear to everyone or not? These propositional functions like taller x comma y, this will be given to you in the yes question statement also. Isn't it? Yes, tell me, this one is clear to everyone or not? Yes guys, tell me. Isn't it? Yes, tell me. Okay, so can I proceed further? Yes, you can take, because there is no variable here, boys of x, there is no variable, yes, y here, so there won't be any effect. Yes, you can take it outside also. Yes or no? But you can understand it clearly when it will be inside the bracket, because you will understand that whenever there is for every, then there will be a yes, what implication. Isn't it? Yes or no? Yes, because there is no variable inside boy. Yes, that is why. So we can take it outside also. Yes or no? Yes, tell me, this one is clear to everyone or not? Isn't it? Okay. Yes, it will be. Yes, you can take. Yes, we can take it after there exist. After there exist. After there exist, there will be a yes for everyone. Isn't it? So there exists yes some boy, we can say that for every girl. Yes, so meaning of there exists for every boy is what? There exists one boy that is taller than every girl. And if you take for every y there exists x, then the meaning will get changed, and then the meaning is for every girl there exists one boy. Yes, tell me, for y2 there exists one boy. Yes, for y3 there exists one boy. And if it is x1, then it is, let's say, x2, that is, let's say this one is x1, then whole entire meaning will get changed. That's why I am saying you, Yes, there exists X will be, yes, at first, and then after there will be for everyone. Yes or no? Because the question statement is some boys in the class are taller than all the girls. That means there exists at least one boy that is taller than every girl. So we will write it like that. There exists X for everyone. Because the meaning of for everyone there exists X is a different. What is the whatever is given in the question statement? Yes or no? Yes, tell me this one is clear to everyone or not? Yes, unique X. Yes, according to this statement, unique X must be satisfied with every girls. Yes or no? Some boys in the girls, yes, some boys in the class are taller than all the girls. The meaning is that only, yes, there exists at least one boy that is taller than every girl. Yes or no? Isn't it? Tell me, this one is clear to everyone or not? Yes. So write down next one. Yes, write down next one. So our next topic is argument. So we can say that an argument in propositional logic, yes, is a, we can say that is a, yes, sequence of propositions that end with, yes, that end with a conclusion. Yes or no? So that is known as what? Argument. Argument is what? An argument in propositional logic is what? Is a sequence of propositions. Yes, we can say that sequence of propositions that end with a conclusion. Yes or no? So you can say that. Let us consider one example. Let's say this is given to you. If you have, yes, if you have current password, if you have current password, then you can log, then you can log onto the network. Isn't it? One statement, logical statement is given to you, followed by another statement that is you have current password. You have current password. And finally, yes, it is given that therefore means after therefore there will be a conclusion. We can say that you can, yes, you can log onto the network. Yes, we can say that, yes, it is a sequence of propositions that ends with what? That ends with conclusion. Yes or no? That is known as what? Argument. So let's say it is written like that. Let's say this is your first proposition. Let's say P1, and this one is your second proposition. So it is written like that P1, yes, P2, then there will be a conclusion. So we can say that, yes, that is the format of an argument. Yes or no? That is known as what? Argument, or we can say that it will be the format of the argument. Isn't it? So these propositions before the conclusion, these propositions are known as what? Premises. Isn't it? These are known as what? Premises. Yes or no? Isn't it? Okay. So write down next. Yes. Write down next. Not, yes, all propositions, we can say that all propositions, yes, except final one, are called as what? Are called as premises. Isn't it? And we can say that, and the final proposition is known as what? final proposition is called as conclusion, isn't it? So now there will be a term that is valid or invalid argument. So when will be the argument is valid and when it is invalid? So we can say that yes, an argument is valid. We can say that yes. If we can say that yes, if it is valid, then we can say that conjunction of all premises implies conclusion is a tautology. Then we'll say the argument is valid. Otherwise, argument is invalid, and invalid argument is also known as what? Fallacy, isn't it? So write down. Yes, we can say that yes, an argument is valid if the, yes, we can say that truth of all its premises, truth of all its premises implies what? Yes, implies that the conclusion is true. Yes or no? Yes or no? Otherwise, it is said to be what? We can say that otherwise it is said to be, yes, it is said to be invalid argument. Invalid argument, isn't it? Or fallacy, isn't it? That means we can say that P1 and with P2 and up to Pn, if implies, yes, we can say that conclusion is a tautology, then we'll say the argument is what? Argument is valid, otherwise argument is invalid, isn't it? Tell me. Yes, tell me guys, this one is clear to everyone or not? Yes, tell me. Yes, now take the example. Yes, let us consider this example only. Yes, you only tell me. If we assume you have current password, if this proposition is represented with P, then you can log onto the network. Let's say this is represented with Q. So can we say that first premise is what? P implies Q. Yes or no? And second premise we can say that is you have current password, that is P only. Therefore the conclusion it is what? Yes, Q only. Yes, this is the format of this particular argument. Yes or no? Can we write it like that? Yes or no? Tell me. Can we write this argument like this or not? Yes, here there are two premises. First one is P implies Q. Second one is P only. And the conclusion is Q. Yes or no? Yes or no? Tell me once, guys. Tell me. Yes or no? Can we write it like that or not? Yes, tell me. Isn't it? लिख सकते हैं ऐसा? Yes. Now tell me, this argument is valid or not? If this argument is valid, then conjunction of, we can say that all premises implies Q must be a tautology. Yes or no? So you can say that P implies Q and with P implies Q. Yes, we'll see this statement is, yes, tautology or not. If it is tautology, then we'll see, yes, we can write it like that. That is the expression, we can write it here. P implies Q, yes, and with Q implies, sorry, and with P implies Q. So we'll see it once. Yes, P implies Q can be written like P dash plus Q. Yes or no? And can be, yes, replaced with dot in case of Boolean algebra. Yes, that means this is, yes, this one implies Q. Again, let us consider this one is X, this is Y. So X implies Y is equals to X dash plus Y. So we can write it like P dash plus Q, P, yes, whole dash plus y means q. Yes, you can simplify it further, p dash p plus qp, yes, whole, yes, complement plus q. So it becomes what? 0, and this one will becomes a p dash plus q dash, and this is q. Now you know very well q dash plus q will be 1 only. So p dash plus 1, it will be 1 only, because 1 plus anything is 1 only. That means it is true. True means it is tautology. So we can say that this particular argument is a valid argument. Yes or no? Yes, tell me, this one is clear to everyone or not? Yes, tell me once. Yes or no? ओके, सो गाइस एक और तरीका है, ध्यान से देखना। यस, आप ऐसे भी बोल सकते हो, यस लिसन मी करेक्टली, इफ यू नीड टू चेक वेदर दिस आर्गुमेंट इज वैलिड और नॉट, then assume all the premises to be true. Assume all premises to be true, and if by assuming all premises to be true, if with the same assumptions your conclusion is also true, then we'll say that is valid argument. Yes or no? So you can do it like that. Let us assume, yes, if this premises is to be true, then we need to assume p value, yes, as true. Yes, so p, we already assumed that p is true. Yes, so yes, if p1 is true, then we need to assume q also to be true only, because if p is true and q is false, then first premise will becomes false. Yes or no? Now we assume that p is true and q is true. With these assumptions, you can see all premises are true only, and with these assumptions we can say that yes, conclusion is q, and that is we assume that is true, so we can say that it is also true. So we can say that yes, that is your valid argument. Yes or no? Can we say or not? Isn't it? Yes or no? ऐसा क्यों अज्यूम कर रहे हैं अपन? क्योंकि अल्टीमेटली वी आर राइटिंग ऑल, यस, कंजक्शन ऑफ ऑल प्रेमिसेस implies conclusion. So whenever it is true, then q must be true, nothing else. Yes or no? Nothing else. Isn't it? Tell me guys, this one is clear to everyone or not? Yes or no? Yes. Is there any doubt? Yes. Okay. Right on, next one, that is very important. Let's say second topic is your rules of inference for propositional logic. Yes, rule of inference is for, yes, propositional logic. So guys, we can say that some, yes, we can say that some standard, listen me correctly, some standard valid arguments are called as what? Rule of inference, nothing else. Isn't it? That means some standard valid arguments are, yes, called as what? Rule of inference. Yes, and we can say that yes, these standard rule of inferences will be helpful to prove some complex arguments, yes, to be valid or invalid. Isn't it? Tell me. So we can say that some standard or basic valid arguments are known as what? Rule of inference. And these rule of inference will be helpful to us to prove any complex argument to be valid or invalid, nothing else, isn't it? So write down, yeah, some standard, we can say that some standard valid arguments, we can say that, are called as what? We can say that are called rules of inference, isn't it? Rule of inference. And we can say that these rules, we can say that, can be, yes, used as, yes, building blocks, yes, building blocks to construct, we can say that, to construct more complicated valid arguments, isn't it? Complicated valid arguments, nothing else, isn't it? Okay, so listen me correctly, guys. Yes, construct one table which contains some rule of inferences. Yes, so construct, yes, there will be three column headers. First one, you can write down rules of inference. Second one, we will see whether it is tautology or not. And third one, we'll see what is the name of this particular rule of inference, isn't it? Yes, you only tell me. Yes, guys, you only tell me these are important and what is the, yes, use of these rule of inferences. We'll see by taking one example also, isn't it? Yes or no? Yes. So yes, you can see, yes, Kenneth Rosen is the ultimate book for discrete mathematics. You can see from there also. Okay, so write down first one, yes, first one, yes, P, and then P implies Q, therefore Q. Yes, you only tell me this argument is valid or not. Tell me once. Yes, you only tell me this argument is valid or not. Yes, we can see it like that. Yes, yes, conjunction of all premises, yes, followed by, yes, we can say that implies, yes, conclusion. You can see it is a tautology, yes or no? Or we can assume all premises to be true. Let's say, to assume first one P1 and P2, if P1 is true, then P must be true. So we will assume that proposition P is true, and if P is true, then Q must be true, yes, for P2 to be true, yes or no? And with these assumptions, we can say that we already assumed Q value to be true. So we can say that if premises are assumed to be true, then conclusion is also true. Otherwise, you can see by simplifying this expression, and you will see this expression is a tautology. So we can say that this is a valid argument, and the name of this valid argument is what? Yes, modus ponens. Yes or no? What is the name of this valid argument? This is the modus ponens. Yes or no? Similarly, you can verify second one. Let's say negation Q, then P implies Q, therefore, yes, negation P. Now you only tell me whether this argument is valid or not. Yes, you can check. Yes, yes, we can say that conjunction, yes, conjunction, we can say that conjunction of all premises. So negation Q and with, yes, P implies Q implies negation P. You can see that this one is a tautology. Yeah, simplify it. The value of this expression will be what? Yes, we can say that true only, isn't it? Otherwise, you can assume the premises to be true and check whether the conclusion is also true or not. So for yes first premises to be true, we need to assume Q value, yes, to be false. If Q is false, then negation Q will be true only. So we already assumed Q value to be false, then P must be false, yes, for P2 to be true. Yes or no? So with these assumptions, we can say that conclusion is also true because we assumed P value to be false. So negation P will be true only. Yes or no? So we can say that this is tautology. So this one is also valid argument, and the name of this argument is known as what? Modus tollens. Yes or not? Tell me this one is clear to everyone or not? I will take one example how these rule of inferences are useful, yes, to construct some complicated valid arguments. So first I finish out these rule of inference. After that I will take one example. Yes, that will clarify you guys that what is the use of these rule of inferences. Isn't it? Tell me, this one is clear to everyone or not? Yes? Yes or no? Okay. So write down next one, third one. This is P implies Q and Q implies R. Yes, therefore P implies R. So you can check, yes, P implies Q and with Q implies R, yes, implies conclusion. P implies R, you can check it. This one is a tautology. So we can say that this one is also valid argument. And the name of this valid argument is, yes, hypothetical, yes, syllogism. Isn't it? Syllogism. Isn't it? Next one, fourth one, you can write down, yes, P or Q, negation P, therefore Q, it is also valid argument. You can verify this is P or Q, yes, and with negation P implies we can say Q, you can simplify it and check once. This one will be tautology. So this one is your disjunctive, yes, syllogism. Isn't it? Next one, yes, next one, write down fifth one, only P, therefore P or Q. Yes, it is also valid because then when this premises is to be, yes, is assumed to be true, then we can say that true or anything will be true only. So we can say that P implies P or Q will be a tautology, and the name of this rule of inference is addition. Next one, you can see sixth one, that is P and Q. Therefore, P, it is also a tautology. So we can say that, yes, P and Q implies P. This is a tautology, and this one is known as what? Simplification. Yes, guys, tell me, noted or not? Tell me once, guys. Yes. Yes, tell me this one is clear to everyone or not? So once it is completed, then we will see by taking one example that what is the use of these rule of inferences. These are some basic, or we can say that a standard, yes, valid arguments, and some naming is given to these arguments, and these are known as what? A rule of inferences. Isn't it? Yes. Write down next one, seventh one. Yes. Two premises are given P and Q. Therefore, P and Q. This is also, yes, tautology. You can see P and Q implies, yes, P and Q. This one will be a tautology. And name of this is conjunction. And final, eighth one is what? Eighth one is P or Q. Then negation P or Q, therefore Q or R. So we can check it, yes, P or Q, and negation P or R implies we can say that Q or R is a tautology, and name of this rule of inference is resolution. Isn't it? ऐसा नहीं है ये आपको याद करने, ठीक है, कहीं पे याद करने की जरूरत नहीं है, क्योंकि जब भी आपसे पूछा जाए whether this one is valid or not, yes, you can apply this procedure and check once it is tautology or not. If it is tautology, then it is valid. ठीक है, बट कुछ एग्जाम्स होते हैं गेट में कभी भी इनकी नेमिंग आपसे नहीं पूछी जाएगी कि व्हाट इज द नेम ऑफ दिस पर्टिकुलर यस आर्गुमेंट, यस ये गेट में नहीं पूछा जाएगा. बट अदर एग्जाम्स हैं, सम यू कैन से दैट इन सम पीएसयू एग्जाम्स और यूजीसी नेट एग्जाम्स, उनमें कई बार डायरेक्टली पूछ लेते हैं व्हाट इज द यस नेम ऑफ दिस पर्टिकुलर रूल ऑफ इन्फरेंस. So one option will be resolution. So resolution will be the correct answer. Nothing else. But for gate point of view, there is no need to remember anything. Yes. Okay. Yes, guys, tell me. Okay. Now you only tell me. Yes. Yes. Take one example. Yes. You only tell me, guys. Yes. Write down first example. Yes. Question number 1. So write down state which rule of inference, you only tell me, is the yes basis of the following argument. You only tell me. One argument is given to you, and argument is it is below freezing, and raining now. Therefore, yes, therefore it is below freezing now. Yes, tell me what is the yes basis of the following argument. Yes, you only tell me. Oh yes, this one is or operator. Yes, this one is or operator. Yes, you can correct it. Yes, tell me. So you only tell me, if we assume P represents, yes, it is below freezing now. It is below freezing now. And let's say Q represents what? Yes, Q represents what? It is raining now. So we can say that this argument is P and Q, therefore P. Now tell me, yes, which rule of inference it is? Yes, tell me. Yes, we can say that this one is your simplification. Yes or no? Yes. So listen me correctly, guys. Next example is important. Yes, next example is important, and we'll see how rule of inferences are useful. Okay, guys? Yes. So write it once. Yes. Write down. Second question. This is very, very important. You only tell me. Check the validity of the following argument. Yes, you only tell me. One argument is given to you. Negation P and Q. Then R implies P. Then negation R implies S, and S implies T, therefore T. You only tell me. Yes, that is the question. You can apply the standard procedure. Yes, that means yes, conjunction of premises implies conclusion. If it is a tautology, then it will be valid, otherwise it will be an invalid. So check it once and tell me what will be the correct answer. Yes, guys, tell me once. That is the given question. You only tell me what will be the correct answer. Yes, you only tell me. This one is valid or invalid argument. Yes, nothing else. Let us assume this one is premises P1, that is P2. These are the premises, and after therefore there will be a conclusion. So if P1 and P2 and P3 and P4 implies T, if it is a tautology, then only we'll say this is valid, otherwise invalid. Yes, tell me. Yes, yes. No need to, yes, no need to construct any truth table. Yes, just apply this procedure, that will be the sufficient. Yes, so we can write it. Yes, negation P and Q, and with, yes, R implies P, and with we can say that, yes, negation R implies S, and with we can say that S implies T, whole implication implies T. Now we'll check it once, yes or no. So you can see this one can be written like P dash Q, yes or no, and means dot only. So implication can be simplified like that, R dash plus P, and this one can be written like that, R plus S, and this can be written like S dash plus T. Yes, we can say that this implies T, and let us assume this one is X, this is Y. So X implies Y is what? X dash plus Y. So we can take, yes, whole complement. So it will become P dash Q, R dash plus P, yes, R plus S, then S plus T, yes, whole complement plus T. Yes or no? Now you can simplify it by applying De Morgan's law. So it will become P dash Q R dash, then RS dash plus RT plus ST. Yes, you can simplify. All remaining terms, yes, are going to be zero only. Yes, sorry, complement plus T. So it will becomes what? P dash Q R dash S T whole, yes, complement plus T, and this can be written like P plus Q dash plus R plus S dash plus T dash plus T. Yes or no? You can see T plus T dash will be 1 only, and 1 plus anything will be 1 only. So we can say that truth value is true only. So it is a tautology, and if it is a tautology, so we can say that, yes, this is a valid argument. Yes or no? That is the valid argument. Yes or no? Isn't it? Tell me. Yes or no? Now see, this is the simple procedure, so that you can use in the GATE examination or any examination also. But by using a rule of inferences, how we can build this particular argument? That is the, yes, that is the question, or that is the task. Isn't it? ये सभी को पता है, सिंपल है, ऐसे आप कर लोगे. बट इसी क्वेश्चन को आप देखते हैं, ये जो वैलिड आर्गुमेंट है, ये आप कैसे रूल ऑफ इन्फरेंसेस से कंस्ट्रक्ट कर सकते हो, दैट इज द क्वेश्चन. सो ये नोट डाउन किया, इसको इरेज कर रहा हूं मैं. नाउ विल सी दिस पर्टिकुलर क्वेश्चन विद द रूल ऑफ इन्फरेंसेस आल्सो. इजंट इट? यस और नो? Okay, so I think everybody noted this one. Now we'll see how rule of inferences are used to construct this particular argument, isn't it? So I am erasing this one, and now we'll see, yes, how to construct this particular argument with the help of rule of inferences. Rule of inferences. Yes or no? Okay. So listen me correctly, guys. You only tell me what will be the correct answer. Yes, first one we'll see. Yes, by using rule of inferences. Yes, you only tell me. First premise is given to you negation P and Q. Let us assume this one is one premise given to you. Premises are also known as what? Hypothesis. Isn't it? Now you only tell me, yes, you only tell me if I apply, yes, if I apply the simplification rule of inference, so can we say that, yes, this implies a negation P, yes, when simplification is used. Yes or no? Simplification using 1. So what is simplification? Simplification is P and Q, therefore P. So if it is negation P, then it will be negation P. So with the first premise, can we conclude second one or not? Yes or no? With the first premise, tell me, can we conclude second one or not? Yes, we can conclude by using simplification. Yes or no? Now you only tell me. Yes. Now third will take, yes, this particular hypothesis, that is R implies P. Yes. Let us consider this one is premise, or we can say that hypothesis. Now you only tell me. Yes. If we apply, you only tell me modus ponens, or sorry, modus tollens. Yes, using, yes, using 2 and 3. Now you only tell me, if we apply modus tollens in 2 and 3, then what will be the conclusion? Yes, tell me. Then what will be the conclusion? Yes, tell me. What will be the conclusion? Guys, ये simplification rule लिखा है इधर, देख लो आप. P and Q means P only. P and Q, therefore P only. So if it is negation P, then therefore there will be negation P, nothing else. Yes, you only tell me. Yes, we apply, if we apply modus tollens in 2 and 3. Now tell me, if modus tollens is applied, then what will be the conclusion? Yes, yes, correct. Yes, good. Then the conclusion will be what? Negation R. Yes or no? Yes, if we apply modus tollens in 2 and 3, then the conclusion will be negation R. So we already covered two hypotheses. Now third one, let us take third one. So third one is negation R implies S. Now apply, yes, you only tell me this one is your hypothesis. Now you only tell me, if we apply modus ponens, yes, if we apply modus ponens in 4 and 5, yes, you only tell me, if modus ponens, this rule of inference is applied between 4 and 5, then what will be the conclusion? Yes, tell me, what will be the conclusion? You only tell me. Yes, tell me once. What will be the conclusion? Yes, correct. The conclusion will be S only. Yes or no? The conclusion will be S only. Yes. Now take, yes, last hypothesis. Let's say this one is S implies T. Now consider this one is the next hypothesis, or we can say that next premise. Now you only tell me, if we apply, yes, modus ponens, yes, in 6 and 7. Yes, you only tell me, if modus ponens is applied in 6 and 7, then tell me what will be the conclusion. Then what will be the conclusion? You only tell me, guys. Yes, then the conclusion will be T only. Yes, that is, yes, that is to be proved. Yes or no? यही आपको प्रूव करना था. तो 4 हाइपोथेसिस आपने और प्रेमिसेस लिए और आपने रूल ऑफ इन्फरेंसेस का यूज किया और आपने क्या कंक्लूड किया? यस, दीज इंप्लाइज यस टी ओनली। यस और नो? यस, कैन वी से और नॉट? टेल मी। Yes, so we can say that yes, we can say that hence the given argument is valid. Yes or no? Hence the given argument is valid. Yes, tell me, this one is clear to everyone or not? Yes, tell me. So can we say or not? You only tell me. Yes, you only tell me. Yes, with the help of these premises, or we can say that some standard valid arguments, we constructed one complicated argument or not? Yes or no? With simple or standard arguments which are known as what? Rule of inferences. And by using these rule of inferences, we constructed one complicated argument. Yes or no? Yes. So that is the use of rule of inferences, nothing else. Yes, tell me, isn't it? सो गेट में आप ये अप्लाई मत करना, मैं आपको सजेस्ट करूंगा, बिकॉज आपको कई बार ठीक है स्ट्राइक नहीं करना करेगा, कई बार आपको पता भी नहीं चलेगा कि ये कौन सा रूल ऑफ इन्फरेंसेस यहाँ पे लगाएं। ठीक है, तो जो सिंपल आपका मैंने बताया, यस कंजक्शन ऑफ ऑल प्रेमिसेस इंप्लाइज यस कंक्लूजन is a tautology, then it will be valid, otherwise invalid. Yes or no? Yes, tell me. This one is clear to everyone or not? कुछ स्टूडेंट्स जो स्टूडेंट्स अपने सेमेस्टर में जहां पे डिस्क्रीट मैथ्स होता है आपके बीटेक में, वहां पे अगर अपन बात करें, ठीक है, एकेडमिक्स की अगर बात करें, सेमेस्टर एग्जाम्स की अगर बात करें, तो वहां पे ये प्रोसीजर आप अप्लाई कर सकते हो। यस, ये प्रोसीजर अप्लाई करोगे तो आपका आंसर जो भी होगा दैट विल बी यस वी कैन से दैट यस इम्प्रेसिव ओनली। Yes, because you are using rule of inferences, yes, to build or construct any complicated argument, isn't it? Yes, tell me. This one is clear to everyone or not? Because this one is yes, yes, this one is valid. Why? Because we reached yes to the or up to the conclusion. Yes. Okay. Okay. So guys, listen me correctly. So this is the use of rule of inferences. So you can practice more questions from the book that is Kenneth Rosen, isn't it? That is very good book for discrete maths. And the style of that particular book, we can say that that is in the Gates fashion, isn't it? Okay, so all questions you can see in the Kenneth Rosen are yes, we can say that like previous year gate questions only. Okay. Yes, we'll take yes one test or we can say that previous year questions yes on Unacademy learning app. So in coming 1 or 2 days we will be having definitely we will be having one problem solving lecture on discrete mathematics. Okay, in which we will discuss all previous year questions in detail. Okay, so I will notify you guys in the group also, Telegram group also, isn't it? Okay, now these rule of inferences are for what? Only prepositions. आपने देखा यहाँ पे कोई भी quantifiers नहीं थे, yes or no? यहाँ पे कोई भी quantifiers नहीं थे, yes or no? Isn't it? Now next we'll see some rule of inferences for quantified statements. So write down next one. Yes, that is also important. Next one is yes, rule of inferences, we can say that the rule of inference is for quantified statements, isn't it? So here there will be, yes, quantifiers like universal and existential. So how we'll see what rule of inferences are used in quantified statements and how these rule of inferences are used to construct, yes, some complicated arguments which includes quantifiers, isn't it? Yes or no? So in these we'll see, first one we'll see universal instantiation. Secondly we'll see universal, yes, universal generalization. Third one we'll see existential, yes, existential instantiation. And next one we'll see, yes, existential, yes, generalization, isn't it? So there are four rule of inferences for quantified statements. Okay. So what is the meaning of these rule of inferences and what exactly these rule of inferences are? Okay. All these things we'll see in the next lecture also. Yes or no? Why? Because if I start these, then it will be very difficult to finish out these rule of inferences. So in the tomorrow's lecture, we'll see rule of inferences for quantified statements, isn't it? Okay, guys. Okay. So guys, there will be one, yes, we can say that problem solving lecture on a discrete mathematics, or we can say that mathematical logic. Okay, and that will be on Unacademy learning app. So follow me on Unacademy learning app. First download Unacademy learning app from Play Store or down or Apple Store, and after downloading you can follow me. My profile link is given in the description of this video. From there you can follow me so that you will be getting the notifications regarding, yes, live sessions that will be regarding to test and quizzes. Okay guys. Okay. Also, you can join our Telegram group. Also, the description of that particular, yes, we can say that the link of that particular Telegram group is given in the description. From there, you can follow or you can join Telegram group also. Okay, guys. So I think that is sufficient for today's lecture. So we'll continue in the, yes, coming lecture. What are the rule of inferences for quantified statements? So guys, you can subscribe our channel. Channel name is Let's Crack GATE CSE. Also press the bell icon to get the notifications and use my code, that is day1, yes, to get the, yes, discount of 10% for plus subscription. So you guys, if you want the subscription, then use my code day1 DEV1 during subscription and get a discount of 10%. And if you want to take the subscription, then take it as soon as possible because there will be a hike on price from 20th October onwards, isn't it? Okay guys, so use my code, that is day1, and get a discount of 10%. Okay guys. Okay, so thank you so much. Okay. 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 So thank you so much. Okay. Also, there will be a lecture on computer organization also tomorrow. Okay. And the timings for computer organization will be from 5 to 7 only. Isn't it? Okay. Thank you so much, guys. So I'm going to close the session. We'll continue tomorrow. Thank you so much.